Multivibrators, regenerative circuits for timing applications. Types: astable multivibrator, monostable multivibrator, bistable multivibrator. Introduction. An astable multivibrator, often called a free-running multivibrator, is a rectangular wave generating circuit. Unlike the monostable multivibrator, this circuit does not require any external trigger to change the state of the output, hence the name free running. So this is the circuit of an astable multivibrator. The resistors R1 and R2 form a voltage divider network, and a fraction beta equal to R2 divided by R1 plus R2 of the output is fed back to the input. The output can take values of plus beta V saturation or minus beta V saturation. The voltage plus or minus beta V saturation acts as V reference at the plus input terminal. The output is also connected to the negative input terminal through an integrating low pass RC network. When the voltage VC across capacitor C just exceeds the V reference, switching takes place, resulting in a square wave output. The capacitor C with its voltage shown as VC starts charging through resistor R towards plus V saturation. The voltage at the positive input terminal is held at plus beta V saturation, as indicated by the use of R1 R2 potential divider network. The charging of C continues until the voltage VC at the negative input terminal is just greater than the voltage at the positive input terminal plus beta V saturation. When this happens, as shown at point B, the output is switched down to minus V saturation. The voltage beta V naught across the capacitor now starts discharging through resistor R and charging towards minus V saturation. The capacitor voltage VC now becomes increasingly more and more negative, and at point C just exceeds minus beta V saturation. The output now switches back to plus V saturation and the cycle repeats. Uses of the stable multivibrator: flashing LEDs, pulse width modulation, pulse position modulation, periodic timers. Next we shall focus on monostable multivibrator, also called a one-shot multivibrator. This has a stable state and a quasi-stable state. Single output pulse of adjustable time duration in response to a triggering signal can also be generated using the monostable multivibrator. So this is the circuit diagram of monostable multivibrator. When the output V0 is at positive saturation, the diode D1 clamps the capacitor C voltage VD, which is approximately 0.7 volt. This is the stable state of the circuit. In this state, the inverting terminal B is clamped to ground by diode D1. This results in preventing the inverting input terminal going more positive than VD. This makes terminal A positive by the same voltage VD. A negative going narrow trigger pulse is passed through differentiator R3CT and diode D2 and connected to the non-inverting input terminal. When a negative trigger signal Vt is applied to the positive terminal, the effective signal is less than 0.7 volt. That is, voltage at positive terminal is beta V saturation plus of minus Vt, which is less than 0.7 volt. Then the op amp switches from plus V saturation to minus V saturation. The diode is now reverse biased and the capacitor C starts charging exponentially to minus V saturation through the resistance R in the closed loop. The voltage at positive input terminal is minus beta V sat. While charging exponentially, just as the capacitor voltage Vc becomes slightly more than minus beta V saturation, the voltage at negative terminal becomes more negative than at positive terminal. Then the op amp output switches back to plus V saturation. The capacitor C now starts charging towards plus V saturation through the resistance R.